This is part 4 of sections 5.1 and 5.2. We want to simplify this, and this is as hard as they get in this course. We not only have two fractions that we need to simplify, but we have to multiply them together at the end. Okay? There are a couple of things you can do here. Let me just get my card with all of my rules on it. You could, flip these. We have a rule that lets us do that to take care of those outer exponents. We could simplify inside each one. We could take this exponent and apply it to the top and the bottom and then go from there. But there's actually something that we can do to make this a lot easier. And I'm going to work it that way just so you can see it. The other way will work is kind of plotting. I can show you how it's done, but if you notice that both of these are raised to the same exponent, we can use this property backwards. Okay? We have this side. We have two things multiplied together raised to the same exponent. So we can multiply them together inside parentheses and then with only one exponent. So if I use property 8 in reverse, we can rewrite this problem as 5z cubed over 2a squared times 8a to the negative 1 over 15z to the negative 2, and then outside that it's raised to the negative third power. Now this is nice because we can simplify inside here. We can make these numbers smaller and then it's all going to be easier. And again, because it's a multiplication problem, that's what I did. If I were just asked to simplify these, I wouldn't be doing this. Okay, so we know we can cancel on diagonals. So if I divide this by 2, I get a 1, divide this by 2, and I get a 4, which is nice. Okay, if I divide this by 5, I get a 1, divide this by 5, and I get a 3. Okay, so what I'm going to do now is I'm just going to multiply straight across in here to see what we have. I have z cubed over a squared times 4a to the negative 1 over 3z to the negative 2, and that's all raised to the negative 3 power. Okay, now what I'm going to do is on the inside here, I'm going to take care of those negative exponents so I can multiply the fractions together. So this is property number 6 that I'm about to use here. And the first fraction stays the same. Z cubed over a squared times the 4 and the 3. Those are both raised to the first power, so they are not going to move. I have 4z squared comes to the top, and then the a to the first power moves to the bottom. So it's a, you don't have to write the first power, to the negative 3. Okay, and now we can multiply straight across, which will give me 4z. I'm multiplying these together, right? And if I'm multiplying two together with the same base, I add those exponents. So this is property number 1, which I usually write in red, but I didn't this time. Okay. Z to the 3 plus 2 is 5 over 3. That's an understood first power. A times a squared is going to give me a cubed. And all of this is raised to the negative 3 power, which is a much nicer look. Okay? So now I have a fraction that is raised to a negative exponent. So I'm going to use property number 11 and flip the fraction on the inside, and then the power becomes positive. So this is property number 11, which gives me 3a cubed over 4z to the 5th, and now it's raised to the positive 3 power. Okay, now the next two steps I'm going to do are ones that people often combine in their heads. I'm going to write it all out, but just know that it's going to be fairly common to skip a couple of steps here. What I have is a fraction raised to a power, and property 9 says I can apply that exponent to the top and the bottom. So this is property number 9, and it gives me 3a cubed, in parentheses, to the third power, over 4z to the fifth to the third power. Okay. Now property number 8, like I said, these all go together most of the time. Property number 8, I get to take, if things are multiplied together, I get to take that outer exponent and apply it to each one. So this is property 8, and I get 3 cubed, a cubed, cubed, over 4 cubed, z to the fifth to the third. Okay, z cubed is 27. A to the third, that's property number 7. I should add those exponents, so I get a to the 9th, and this is property 7. 4 cubed is 64. Z to the 5th to the 3rd, multiply those exponents together, and you get z to the 15th. Okay, so now we're going to go on to an application of this stuff. We're going to talk about scientific notation. I know you've done this before. It's usually not that difficult, but it does go in with our exponent rules. We're going to rewrite each number with one non-zero number in front of the decimal point, and then we're going to adjust the value by multiplying by a power of 10. It is always a power of 10. Okay? This is the only time we use x for multiplication in this class. In my math lab, make sure you use the x on the toolbar. Do not use the one on the keyboard. It will count it wrong. After you click in the box for your answer, the toolbar will pop up in the bottom and you will see a regular X down there, and you're going to have to click that one. So this is how you're going to get those done. Okay, let's rewrite these following numbers in scientific notation. We want to take this decimal point. We don't like having all these zeros. When you start to do calculations with them, it's easy to drop one and you mess everything up. Okay, so we don't want to do that. I want to get rid of as many of these zeros as I can, so I'm going to take this decimal point and I'm going to move it over to here. We need one non-zero number in front of the decimal point. So I'm moving this decimal point over to here. I'm moving it between the 7 and the 2. So I have 7.2 times. It's always a power of 10. We just have to figure out what power. Okay? Now your exponent is either going to be a positive or negative version of however many spaces we moved this. I moved the decimal place 1, 2, 3 spots. So my exponent is either going to be positive 3 or negative 3. You could memorize which way it goes. I suggest that you don't, okay? Ask yourself, okay, this is what I've got right now. I need to change it back to this. This is supposed to change this back into this. Do I need to be making this bigger or smaller to go back to here? Well, I need to be making, 7.2 is a lot larger than this, so I need to be making it smaller. And if you need to be making it smaller, you're going to use a negative exponent. Okay? On these calculators, where is it? Oh, it's the EE button on this calculator. Okay, so if I wanted to do 0.00, well, I'm backwards. Let's check this. 7.2, and then you hit that EE button, and that counts as times 10 to times 10, and then you just type in the exponent here, and it gets you back to here. So they are equivalent. Okay, you could also do it as 7.2 times 10 and raise 10 to the negative 3 power. You can type it in directly, and you'll see that it's the same thing. Okay, now for this one, we are supposed to be transforming a negative number. It is going to be a negative number. These two sides are supposed to be exactly the same value, just written in a different form. So you move over the negative, and then you don't have to think about it anymore. So we just, after this point, pretend that negative doesn't exist. So I'm going to take my decimal point, which is understood to be right here, and I'm going to move it. Again, we have a lot of zeros here, a huge opportunity to make a mistake. When you're typing this in on your calculator, you type in too many zeros or not enough, and you're off by powers of 10, and it's just not good. So I'm going to take this and I'm going to move it. So I have one number in front that is not a 0. That means I'm moving it between the 9 and the 6. So I have negative 9.67, and then I can drop all of those zeros. Okay, times 10 to some power. How many spots did I move it? 3, 6, 7, 8 spots. Okay, ignoring the negative. Do I need to be making 9.67 bigger or smaller to get it back to here? Well, this is a much bigger number than this. So I need to be making it bigger so it's a positive exponent. Okay, so if I do negative 9.67 and I hit the EE button, and I hit 8 because I'm raising it 10 to the 8th, you can see that double check your zeros and it's the same thing. Okay.